So the other convection process we want to look at is deep ocean convection. And this is pretty similar to the mixed layer convection, except you get a much stronger or much larger buoyancy flux, which gives rise to much deeper reaching plumes. So the larger buoyancy flux usually comes about because of this additional buoyancy input to the ocean, which is through the process of sea ice formation. So in the polar regions, when you form sea ice, the sea ice rejects most of the salt from the water, and so it takes it from the typical concentration of water, which is about 35 grams per kilogram for seawater, down to about 5 grams per kilogram, which is trapped as little pockets of brine in the ice. But that difference of 30 grams per kilogram of salt is dumped into the ocean. And so that makes the ocean surface waters really, really dense, and they sink very rapidly, high Rayleigh number, very turbulent plume, right down to the bottom of the ocean. And so usually this is happening on the continental shelf. So those waters sink down to the continental shelf, and then ultimately they cascade off the continental shelf into the deep ocean and fill up the deep ocean. And so that deep water, what we call deep water formation, during the sea ice formation times of year, so that's obviously in the onset of winter period, is what sustains the deep limb, the sinking, what we call the sinking limb of the global overturning circulation. So that's the region here and here in the North Atlantic, which is driving this formation of deep ocean water. So Nicola will come back to the global ocean circulation later in the course, but it's the convective processes at the poles that are driving the sinking limb of this circulation.